Welcome to Math TV with Professor V. It is Friday, May 5th, 2023, Cinco de Mayo, and here is your integral of the day. So we have an indefinite integral of 3x to the fourth plus 15x squared plus 5 over x cubed plus 5x dx. So if you want to try it on your own first, go ahead, pause the video now. And you might notice it's a rational function, so you're probably thinking, ooh, it's probably time for partial fractions. Not just yet, because notice the degree of the denominator is not higher than the degree of the numerator. So it needs to be a higher degree down here than up top to do partial fractions. So what do we do when it's not? We long divide. So we're going to long divide the denominator, which is x cubed. I'm going to put a placeholder. There's no x squared term, plus 5x, and there's no constant. I'm going to divide that into the numerator, which is 3x to the fourth plus 0x cubed plus 15x squared plus 0x plus 5. If you need a review on polynomial long division, I'll link a video here. So you're just going to look at the leading terms when you divide. So what's 3x to the fourth divided by x cubed? Another way you could think of it is, what do you multiply x cubed by to make it 3x to the fourth? Just 3x. And then you distribute all of that good stuff. So this is 3x to the fourth plus 0x cubed plus 15x squared plus 0x. Subtract all of this loveliness. I like it when it looks nice and clean, so I'm getting rid of that. This cancels, it better. The term farthest to the left should cancel, otherwise you screwed up. And then, ooh, this cancels also. This is all gone, and now I just bring down this last little 5, which is my remainder. How do I know it's a remainder? Because the degree of 5 is 0, right? There's no variables, and that's less than the divisor. So now I know that's my remainder. So how would you put it all together? You would say that this integral now is equivalent to 3x plus 5 over the divisor, which was x cubed plus 5x, and then dx for all of this. All right, so now we will find the partial fraction decomposition just for this term here. Antiderivative of 3x you should be able to do in your sleep, correct? Good, okay. So now here we go, partial fraction time. And I need to factor out that x from the denominator before I get rolling. So we've got 5 over, taking out an x, now I have x squared plus 5 left. So this is a over x plus bx plus c over x squared plus 5. And then now you multiply everything through by the denominator, x squared plus 5, and try to solve for a, b, and c. So here on the left I have 5 equals a times x squared plus 5 plus bx plus c times x. So we have 5 equals ax squared plus 5a plus bx squared plus cx. And one technique to solve for these coefficients is you just equate the coefficients of like terms from both sides of the equation. So what do I mean? Well, what's the coefficient of x squared on the left? It's 0, right? There is no x squared and there is no x. So 0 has to equal a plus b. Okay. Now what about x to the first? Again, 0 is on the left. What are the x's on the right? Just cx. So that means c is equal to 0. And then your constants, 5 is the constant on the left, and 5a is the constant on the right. So 5 must equal 5a. That means a is 1. And if a plus b is 0, then b is negative 1. Okay, so now we can rewrite everything using the partial fraction decomp. So what does that give us now? We have, remember that 3x from earlier? It was so happily minding its business, okay? So bring that 3x down, And then we have plus, a is 1. So you have a over x, that's going to be 1 over x. And then b is -1, so I'm going to write that as minus 1 over 1x, over x squared plus 5, and then dx. Okay. This one we know, 3/2 x squared. This one we know it's antiderivative, ln absolute value of x. This one's going to require a u sub, which I can do in my head. Can you? So you would let u equal x squared plus 5, and then du is 2x dx, so 1/2 du is x dx. And then in the end, because this u is in the denominator, you would have 1/2 1 over u du. Okay, I'm going to put it all together now. So this is 3/2 x squared plus ln absolute value of x minus 1/2 ln, what was u? X squared plus 5. That's always positive, so I don't need absolute value, and then plus c. All right, good. If you need to actually sit there and write out the whole u sub, that's totally fine. I just try to get my students away from it, especially when they're finishing up Calc 2 and they've done so many integrals, because when you're going into Calc 3, you don't want to have to be bothered to stop and write out a u sub for something that's pretty straightforward like this. Okay, so hopefully you're getting more advanced, you're mastering these, and you can skip some steps in your head. It's not a bad thing. If you mess up because you're skipping steps though, then don't do it. Okay, so that concludes the integral of the day. We are starting to review for finals soon. So I do have a final exam review video for Calc 1. I will be working on making one for Calc 2 in the coming weeks. So stay tuned, subscribe if you haven't already. Give this video a thumbs up. Tell me how you liked this integral. I'm pretty sure I haven't done it yet. I have to always go back through and check. If you have any requests, let me know. And you can also follow me on Instagram and TikTok at MathTV with Professor V. And I know I said it's Cinco de Mayo. I don't really celebrate or anything like that. And it's technically not Mexican Independence Day if you check your history, but I think people in the States just like an excuse to party, eat tacos, and have tequila. So hope everyone has a lovely Friday. All right, bye-bye.